Hi friends, welcome to the lecture of linear algebra. In last lecture we have completed what is an annihilator, and now we have to see what is an annihilator of an annihilator. That is, in last lecture we have seen how to find out the annihilator of some set S, which is a subset of a vector space V. Now we have to find out the annihilator of that annihilator of a set S. Before that, let us see one theorem which is depending on the annihilator of a set S. Let S1 and S2 be, let S1 and S2 be two subsets, two subsets of a vector space V, for vector space V, such that S1 is subset of S2. Then S2 annihilator is taking S1 annihilator. That is S2 annihilator is a subset of S1. S2 annihilator is subset of S1 annihilator. Here we have given that S1 and S2 be two subsets of a vector space V, such that S1 set S1 is a subset of set S2. Then we have to prove that S2 annihilator is a subset of S1 annihilator. Given that, let S1 and S2, set S1 and S2 be two subsets of a vector space of V, such that S1 is a subset of S2, and to prove that S2 annihilator is a subset of S1 annihilator. By definition, we know that what is the annihilator of one particular set. Then, by definition of annihilator, by definition of an annihilator, S1 annihilator is nothing but S1 annihilator contains all linear functions belonging to vector space V star, such that f of alpha is equal to 0 for each alpha belonging to set S1. Okay? Annihilator of set S1 is nothing but it contains all the linear functions belonging to the vector space V star, such that f of alpha will be equal to 0 for each alpha belonging to set S1. Similarly, S2 annihilator equal to it contains all the linear functions belonging to vector space V star, such that f of alpha is equal to 0 for each alpha belonging to set S2. So this is from the definition of annihilator. Now we have to show that S2 annihilator is contained in S1 annihilator. If we have to prove that any set A is a subset of B, then how will you prove? We have to take one element belonging to set A and if arbitrary element belonging to set A and this element is belonging to set B, then we say that the particular set A is a subset of set B. Now let F is belonging to S2 annihilator. Okay, as F is belonging to S2 annihilator, then S2 annihilator contains all the linear functionals such that f of alpha is equal to 0 for each alpha belonging to set S2, which implies f of alpha is equal to 0 for each alpha in set S2. But given that S1 is a subset of S2, as every element of a set S1 is an element of set S2, and f of alpha is equal to 0 for each alpha belonging to S2, then f of alpha must be equal to 0 for each alpha belonging to S1, since S1 is a subset of S2, and f of alpha equal to 0 for each alpha in S2, which implies f of alpha equal to 0 for each alpha belonging to S1. If suppose this one is the equation 1 and this one is the equation 2, here we get f of alpha equal to 0 for each alpha belonging to set S1. Then from equation 1, S1 annihilator contains all those linear functionals such that f of alpha equal to 0 for each alpha belonging to S1, and here we get f of alpha will be equal to 0 for each alpha belonging to S1, which implies this alpha, this F is belonging to S1 annihilator, which implies F is belonging to S1 annihilator. So here we get if F is a member of S2 annihilator, which implies F is belonging to S1 annihilator. That is, if we take any functional from S2 annihilator, then it is also a member of S1 annihilator. Therefore, from this we conclude that every element of a S2 annihilator is an element of S1 annihilator. Hence, S2 annihilator is a subset of S1 annihilator, which implies S2 annihilator is subset of S1 annihilator, and that is we have to prove, and hence the okay. Now the next point is annihilator of an annihilator. So now we have to see what is an annihilator of an annihilator of a set. Okay, now let V be a vector space over the field here. Vector space over the field here. Here, and S is any subset of V, any subset of vector space V. Then, in definition of annihilator, we have seen that if V be a vector space over the field F and S is any subset of V, then S annihilator is a subspace of V. Then S annihilator is subspace of V, vector space V. Now, from definition of annihilator, from definition of annihilator, annihilator of S annihilator, that is S to the power 2, that is S annihilator of a set, annihilator of an annihilator, and which is nothing but it contains all linear functionals belonging to vector space V double star such that L of F equal to 0 functional for each F belonging to S annihilator. Okay. Here, annihilator of a annihilator contains all those elements, all those linear functionals belonging to which double star. Since here we have found out the annihilator of a annihilator. So all L belonging to V double star such that L of F is equal to 0 functional for each F belonging to S annihilator. Since here we find out the annihilator of a S annihilator. Okay. Now, and this is called the annihilator of a annihilator set S. Okay. Now, and obviously, S double annihilator is an subspace of subspace of V double star. Since in previous lecture we have proved that if V be a finite dimensional vector space or V be any vector space over the field F and S is any subset of V, then S annihilator is a subspace of V star. Here V be a finite dimensional vector, V be any vector space over the field F and S annihilator is a subset of V star. Then S annihilator is a subspace of V double star according to that result. Okay. Now, if V be a finite dimensional vector space and dimensional vector space over the field F over the field F, and if we identify V double star with V under the natural isomorphism from alpha to alpha, so morphism from set alpha, sorry, element alpha to L alpha, then S double annihilator is nothing but it contains all L alpha belonging to V star such that L alpha of F equal to 0 for all F belonging to S and N. Since we know that there is an isomorphism between the vector spaces V and V double stars, which is already proved in previous lecture. Since if V be any finite dimensional vector space over the field F, then the mapping from alpha to alpha is an onto isomorphism from vector space V onto V double star. So this S double annihilator is nothing but L alpha belonging to V double star, such that L alpha of F will be equal to 0 functional for all F belonging to S annihilator. That is, as there is an isomorphism between vector space V and V double star, then this L alpha is nothing but L alpha of F is nothing but F of alpha, and F of alpha is nothing but alpha, since it is in there is an isomorphism between vector space V and V double star. So elements of V and V double star are isomorphic. So this one is nothing but alpha belonging to V such that F of alpha equal to 0 for all F belonging to S annihilator. And it contains all the elements belonging to the vector space V. So this set is a subset of vector space V. Okay, now we say that S double annihilator is a subspace of V double star, but V double star is isomorphic to V. Therefore, S annihilator is a subspace of V, which implies S double annihilator is a subspace of vector space V. This one is the annihilator of an annihilator. Okay, now we have to see some results depending on this annihilator of annihilator. Let V be a finite dimensional vector space. Vector space over the field F and W is subspace of V. Then W double annihilator is equal to. So here, if V be any finite dimensional vector space over the field F and W is any subspace of a vector space V, then we have to prove that W double annihilator is equal to set W. Sorry, subspace W. As here given that V over F is a finite dimensional vector space over the field F, and W is subspace of vector space V. Now, here we have to show that W double annihilator is nothing but W. To prove that, W double annihilator is equal to subspace W. So, to prove this, let us W annihilator is equal to, it contains all F belonging to V star, that is all linear functions belonging to vector space V star, such that F of alpha is equal to 0 for each alpha belonging to set V, or each alpha belonging to vector space V. Now, from this, W double annihilator is nothing but W double annihilator equal to, it contains all L belonging to vector space V double star, such that L of F is equal to 0 for each alpha belonging to, sorry, here we find out the annihilator of W, that is for each alpha belonging to set W, since we find out the annihilator of a set W. So W double annihilator contains all L belonging to V double star such that L of F equal to 0 for each F belonging to, here we find out the annihilator of set W annihilator. So each F is belonging to W annihilator. Okay, now we know that there is an isomorphism between the vector space V and V double star. So elements are against V and V double star contains the elements of the same type. That is, which is nothing but alpha belonging to vector space V such that F of alpha is equal to 0 for each F belonging to W annihilator. Okay, now let alpha belongs to W be any element. Alpha belongs to W be any element. As alpha belongs to W be any element, but we know that W annihilator contains all those linear functionals such that f of alpha will be equal to 0 for each alpha belonging to W, and as alpha is belonging to W, which implies f of W, sorry, f of alpha is equal to 0 for each f belonging to W annihilator. As alpha belongs to W be any element, then f of alpha is equal to 0 for each f belonging to V, f belonging to V star, but this set is a subset of W annihilator, so it is f belonging to W annihilator. But f of alpha equal to 0 for each f belonging to W annihilator. From this equation, f of alpha will be equal to 0 for each f belonging to W annihilator is nothing but it implies that that particular element alpha is belonging to W double annihilator, since f of alpha equal to 0 for each f belonging to W annihilator, and which is nothing but this one, and for this alpha is belonging to this set W double annihilator, which implies alpha belonging to W annihilator. So here we have taken one arbitrary element which is belonging to set W, and from this we prove that alpha is belonging to W double annihilator. So from this, W is subset of W double annihilator, since every element of W is an element of W double annihilator. Now here W is subspace of V, subspace of V, and W double annihilator is a subspace of V double star, but V double star is isomorphic to V, therefore W double annihilator is also a subspace of V, and W double annihilator is also a subspace of V. And we know that if A and B are two vector spaces, A and B are two subspaces of same vector space V of V, and A is subset of B, A is subset of, say, A vector subspace A is subset of subspace B, then A is subspace of B, subspace of V. This is in general. If A and B are two vector subspaces of a vector space V, and subspace A is a subset of a subspace B, then this subspace A is a subspace of vector space V. Okay. Now from here, as W and W double annihilator are two subspaces of a vector space V, and W is a subset of W double annihilator, which implies W is subspace of vector space W double annihilator. Okay. Now let us take this one as a 1. As W is subspace of V, subspace of V. We know that if V be any finite dimensional vector space over the field F and W is any subspace of V, then in previous lecture we have proved dimension of W plus dimension of W annihilator will be equal to dimension of V. So from this theorem, dimension of W plus dimension of W annihilator is equal to dimension of vector space V. Let us take this equation as a equation 2. Now, applying this same theorem on W annihilator, as we know that W annihilator is a subspace of V star. W annihilator is a subspace of V star. So applying the same theorem, on W annihilator. So as W annihilator is a subspace of V star, which implies dimension of W annihilator plus dimension of W annihilator is equal to dimension of vector space V star. But we know that dimension of V star is equal to the dimension of a vector space V, since the basis elements of both the set contains the same elements. The number of elements in both the bases, that is for V star and V, contains the same elements, which implies dimension of V star is equal to dimension of a vector space V. But dimension of vector space V from 2, dimension of vector space V is nothing but dimension of W plus dimension of W annihilator, which is equal to dimension of W plus dimension of W annihilator. So here we get dimension of W annihilator plus dimension of W annihilator of an annihilator, which is equal to dimension of W plus dimension of W annihilator. But as V is a finite dimensional vector space and W and W annihilator are subspaces of V and V star, so these have these subspaces have also a finite dimension. So dimension of W annihilator and dimension of W annihilator gets cancelled, which implies dimension of W is nothing but the dimension of W annihilator of annihilator. Now this one is suppose equation 3. Equation 1 says that W is a subspace of W double annihilator. W is a subspace of W double annihilator and dimension of W is equal to dimension of W double annihilator. It implies that these two equation 1 and 3, these conditions are possible if and only if W and W double annihilator are same. Otherwise, it is not possible. Since W is subspace of W double annihilator, then possibilities of W are either W is a zero subspace, or it is a some proper subspace of W double annihilator, or W is equal to W double annihilator. But if we take W as a zero subspace, then dimension of W is 0, which is not equal to the dimension of W double annihilator. Since here we don't know that how much is the dimension of W double annihilator. So W equal to zero subspace is not possible. And if we take W as a proper subspace of W double annihilator, then dimension of W is less than dimension of W double annihilator. So this one is again not possible. Then the third one is dimension of W equal to dimension of W double annihilator. Then and only then W must be equal to W double annihilator. That is sorry, if W equal to W double annihilator, then only dimension of W is equal to dimension of W double annihilator. So hence from these two equations 1 and 3 we conclude that W is must be equal to W annihilator. Otherwise it is not possible that W is any subspace of W double annihilator and dimension of W is equal to dimension of W double annihilator. And that is we have to prove, and hence the proof. Okay. Now the next theorem is let V over here be a finite dimensional vector space, finite dimensional vector space if W1 and W2 are subspaces of V or subspaces of vector space V, then W1 annihilator is equal to W2 annihilator implies and implied by W1 is equal to W2. Okay, so here if V over here be any finite dimensional vector space over the field here, that is V over here be a finite dimensional vector space, and if W1 and W2 are any two subspaces of a vector space V, then we have to show that W1 annihilator is equal to W2 annihilator implies and implied by W1 will be equal to W2. That is, if W1 annihilator equal to W2 annihilator, then W1 is equal to W2, and if W1 is equal to W2, then W1 annihilator is equal to W2 annihilator. True. Let W1 and W2 are subspaces of a finite dimensional vector space of a finite dimensional vector space V over F. Okay. Now, in first steps, that is, suppose this one is the part one. Let W1 annihilator is equal to W2 annihilator, and to prove that W1 is equal to W. Okay, as W1 annihilator is equal to W2 annihilator, which implies W1 double annihilator must be equal to W2 annihilator. Since W1 annihilator and W2 annihilator are equal, and if we take annihilator of these two subspaces, then which is again equal, that is W1 annihilator must be equal to W2 annihilator. But from previous theorem, we proved that if V be any finite dimensional vector space over the field F and W be any subspace of vector space V, then W double annihilator will be equal to W. So from this W1 double annihilator is nothing but W1, and W2 double annihilator will be equal to W2, and that is we have to prove. So if W1 annihilator is equal to W2 annihilator, then W1 must be equal to W2. Now in part 2, let W1 is equal to W2, and we have to prove that W1 annihilator is equal to W2 annihilator. Now first find out what is W1 annihilator and W2 annihilator. W1 annihilator is nothing but it contains all linear functions belonging to vector space V star such that f of alpha is equal to 0 for each alpha belonging to set W1. Okay, and W2 annihilator is equal to, it contains all the linear functionals from vector space V star such that f of alpha equal to 0 whenever all alpha, that is for all alpha belonging to W2. But here we have given that W1 is equal to W2, which implies, which is nothing but f belonging to V star such that f of alpha equal to 0. Suppose this one is equation 1 for all alpha belonging to, as W2 is equal to W1, which implies alpha is belonging to W1. But from equation 1, f belonging to V star such that f of alpha equal to 0 for all alpha belonging to W1 is nothing but W1 annihilator. W1 annihilator. It is from 1. Okay, so which implies W1 annihilator is equal to W2 annihilator. So if W1 is equal to W2, then W1 annihilator is equal to W2 annihilator, and that is we have to, and hence the proof. Okay, thank you for watching the lecture.